6 marks, GCSE algebraic fractions question, disguised in geometric sequences. Now, GCSE students have always struggled with geometric sequences because we don't really dedicate full lessons to this because it's very simple. They don't really do much with geometric sequences. So, yeah, that's basically it. Sometimes teachers don't even teach their students geometric sequences. So what is a geometric sequence? We have the first 3 terms of a geometric sequence are x plus 4, 6x, and 2x squared, where x cannot be 0. Find the value of x. So we are used to sequences such as linear sequences. Linear sequences are where they just go up by the same value, addition or subtraction. Then we have quadratic sequences. Quadratic sequences are one where the second difference is the same. For example, 1, 4, 9, 16, etc. Just the square numbers. So here you're going up by 3. Here you're going up by, so this is plus 3, plus 5, plus 7. So it's an interesting connection there, plus 2. If you were to work this out, this sequence here would be n squared. Yeah, so wherever the term number is, you square it. Now, what is a geometric sequence? A geometric sequence, very similar to an arithmetic sequence or a linear sequence. So here we add 1. Here we're just adding by a constant value. A geometric sequence is one where we multiply by a constant value. For example, if I had 5, 10, 20, 40, here we are multiplying by 2 each time. Okay? Now we need to recognize a pattern here, and we need to use the fact that there is a common ratio, we call it. So this here we call a common ratio. We need to use this idea to somehow form a connection here and an equation that we need to solve. Now, I've obviously given you guys this because it's very easy to see. Okay? However, if I gave you other values, it may not be so obvious. Okay? For example, if I just make one up at the top of my head, 81, what was I trying to do? 54, and then what can I do? 48, I think. I'll double check it. But from there, can you see what you're multiplying by? Maybe not. Let me just double check this one. Yeah. No. What was I trying to do? 54. Whoops, that should have been 36. All right. So what happens when you make stuff up on the spot, yeah? Now, even like this, can you see what you're multiplying by? It's not so easy, okay? What you're multiplying by is 2/3. But how can you see that a lot easier? What you're doing is the second number divided by the first. 54 divided by 81. And here is 36 divided by 54. Okay? And they both give you 2/3. That's going to be the same case here. The common ratio needs to be the same. And I can find that through division. Whatever you need to multiply this by to give you this has to be the same as what you multiply this by to give you this. And we can find that out by doing a division. So what you need to multiply this by to give you this, you're doing this divided by this. So it's saying 6x divided by x plus 4 has to be the same as this divided by this. 2x squared divided by 6x. Okay? This divided by this is the same as this divided by this. These two both give you 2/3. 10 divided by 5 is 2. 20 divided by 10 is 2. 40 divided by 2 is 2. And now we need to solve this. First thing I notice is that this can just simplify. Yeah, we can simplify the 2 and the 6. 2 divided by 2 is 1. 6 divided by 2 is 3. And I also know x goes into x squared x times. So x cancels the squared. So we're left with x on the top and 3 in the denominator equals 6x over x plus 4. Now, some students won't see this, but if you want to, you can actually cancel out an x here. Yeah. For example, if I gave you guys this, 2x equals 2. Okay. You'd all divide by 2 and say x is 1. So this is 2 times 1. Here you could cross off the 2. It's the same thing here. Yeah. If you wrote that as x times 1, you could cross off the x and say 6 over x plus 4 equals 1/3. But most students wouldn't see that. That's all good. So I'll do it assuming you guys didn't see that. But if you did, let me know. So, how do we solve this if we didn't do that? First thing is we're going to protect this with a bracket, and we need to get rid of denominators. So, this says divide by x plus 4. So I'm going to do the opposite. I'm going to multiply both sides by x plus 4. And we need to do the same thing with the 3. This says divide by 3. We're going to do the opposite. We're going to multiply by 3. You might know this is cross multiplication. I don't like this. I don't like explaining it that way, especially to GCSE students, is because they use that in every scenario. Even if I give you 3 fractions, students are trying to do cross multiplication. It doesn't work like that. In this context, it does though. So if you want to do cross multiplication, that's fine. But I like explaining what I'm doing as well. So I'm multiplying both sides by 3. Yeah, to get rid of this denominator. And I'm going to do it with x plus 4. Okay. So the x plus 4 here is going to cancel. I have 6 times 3 is 18x equals, here the 3's cancel. And you're left with x, lots of x plus 4. Here we have another opportunity to cancel out x. Now, here you have to be very careful again. When we divide by x, you have to make sure that x is 0 is not a solution. Because really we should bring everything to one side and factorize. And I've been very clear to say x cannot be 0. So again, you can divide by x here. But most students would just expand this. It's very common for A-level students to do this. So we get x squared plus 4x. Now, to solve this, we bring all the x's to one side. So I'm going to minus 18x. We're always going to bring it to the side of the positive x squared. So this goes. 0 is x squared. 4 minus 18 is minus 14x. Then to solve this, we need to factorize. Here is a simple one. X is a common factor. Then we get x minus 14. Then either x is 0 or x minus 14 is 0. And we already know x cannot be 0. So we're going to move that over. A minus 14 on the left is a plus 14 on the right. And that is our solution. It's not that bad. You just need to understand a bit of theory beforehand. And that's it. You just solve the algebraic fraction. So guys, if you learned something today, I'd appreciate if you hit the thumbs up button, subscribe for more maths content, and if you're interested in my maths courses, link is in the description. And feel free to join the Lung Gang Reddit page if you want to submit your own questions and get feedback from my community. I'll see you in the next video. Nice.